In problem 1.15, we need to find out which of the functions given there meet all the requirements of a probability density function. A and B are both positive constants. So the first probability density given to us is this. This cannot be a probability density because this here is an imaginary value. It's not real. And probability or the probability density is always real. So because we don't have a real value here, A, the function given in A is not a probability density function. B has the probability density function to be x times e to the power negative b x squared. When x is less than 0, the probability density becomes negative. And the probability density cannot be negative, right? When x is negative, the density is negative. However, no matter what value x takes, the probability or the probability density should always be non-negative. So for that reason, the function given in B is also not a probability density function. Number C has a probability density function of e to the power negative b x squared. Now, if we try to normalize this function from negative infinity to infinity, so this function is definitely real and it's definitely non-negative, right? So the last check that we need to do is whether it can be normalized or not. So if we were to do that, we would get to be x squared dx. We can write this as 2 times 0 to infinity to the negative 2b squared times dx. If we look at the integrals in the appendix, we see that if we have an integral of the form e to the power negative cx squared dx, the answer is going to be, or c has to be positive. Now, using this here, we can have the answer to be half pi over, in our case, the c here is actually a negative 2b. Sorry, it's not negative 2b, it's 2b. The c given here is equivalent to 2b of what we have, so it's going to be this. Now, the 2 and the 2 get canceled, and this can be written as pi over 2b under root. Now, we have the probability density to be equal to this value. And we don't know the value of b, we just know that b is a positive constant. So unless b is equal to pi over 2, in which case we would have unless b equals pi over 2, the probability density is not equal to 1. If b, when b is actually equal to pi over 2, then the state function is normalized. So we have a state function that is non-negative, that is real, and that is also normalized. normalized. However, we don't know the value of b, and when b is not equal to this particular value, we can see that this particular state function is clearly not normalized. So I would say the answer to this question would be that A, B, and C are all not good examples of probability density functions. And the important conditions that we need to keep in mind for probability density function is that it has to be real, and it has to be non-negative, and it has to be normalized.